Have you ever driven over a pothole-ridden street or a rugged trail and wondered how your car seems to absorb the chaos, keeping your ride surprisingly smooth? The magic behind this lies in an engineering marvel we often take for granted: the shock absorber. Far more than just a simple component, it's a critical part of your vehicle's ability to provide comfort, control, and safety. Buckle up as we dive into the manufacturing process and uncover the difference between the shocks in your mom's car and a Formula One racer. The history of shock absorbers can be traced back to the early 1900s, when early vehicle manufacturers began looking for solutions to the problems concerning steering a vehicle in motion and passenger comfort. The first shock absorbers ever invented consisted of two arms connected by a bolt with a friction disc positioned between them. This design made them hydraulic in nature. To adjust resistance, the bolts are either tightened or loosened. As expected, these early shock absorbers are not very durable, and their performance left a huge gap of what is desired to be filled. The Frenchman Maurice Houdel is credited with the invention of the first shock absorbers, which he aimed at taking advantage of the excellent cushioning qualities of hydraulic fluid. He received his first patent for the products in 1907, and his products received wide acceptance and eventually became standard equipment on the immensely popular Model A Ford vehicle in 1927. Over the years, lots of manufacturers continued to develop new designs of this indispensable part, exploring different possibilities to achieve the most effective shock absorber out there. The main component you'll see is the housing, which is cylindrical in shape. It serves as the body of the shock absorber and as a container that holds the piston and hydraulic fluid. Inside the cylinder of your vehicle's shock absorber are a piston rod, hydraulic oil, and a set of valves. The piston, which moves up and down inside the cylinder, contains valves that regulate the flow of hydraulic oil through small passageways. This controlled flow converts the kinetic energy from suspension movement into heat, dampening vibrations and smoothing the ride. The piston rod is attached to the piston and guides its movement, keeping it aligned and stable. Together, these components allow the shock absorber to absorb and dissipate energy, reducing bounce and maintaining vehicle control. To get high-quality shock absorbers that will function for a longer period of time without having any fault, steel or aluminum that have high strength and ability to be bent into different shapes and sizes are chosen for some of the components like the outer cylinder and piston rod. This is needed because of their durability and corrosion resistance. For the bushing components, synthetic materials like rubber or polyurethane are used to ensure longevity and flexibility under varying harsh conditions. First, the metal must be cut and rolled into cylindrical shapes. Once the rough shape has been formed, it's cut into pipes according to the required size. To prevent wear and improve fluid dynamics, the interior surface of the cylinder is polished or treated. A chamfering machine is then used to chamfer the cut pipes. The piston rod is shaped using machines to the required shape and precise dimension, and sometimes chrome-plated to counter resistance and enable smooth movement. Next is the valve components of the piston, which are engineered with lots of precision for the control of fluid flow to determine the characteristics of dampening. This is usually done using the CNC technology to ensure accuracy. But what makes this stage of manufacturing interesting is that depending on the type of vehicle, the process can be a bit different and more sophisticated. Take for instance your Formula One race car. Its shock absorbers are quite different from that of a typical family car because apart from comfort and easy steering, shock absorbers in F1 cars have another important function: platform control. Platform control refers to a race car's ability to maintain stability and balance during high-speed driving and sharp cornering, thanks to its meticulous design and aerodynamics. This involves managing the vehicle's aerodynamic forces, such as downforce and drag, to ensure that the car remains planted on the track. By controlling how air flows around and under the car, engineers optimize its grip, minimize body roll, and prevent unwanted lift, allowing the driver to handle challenging turns and straights with precision and confidence. The need for control at those speeds led to the creation of the multi-rod shock absorber. The multi-rod system uses two wishbone-shaped control arms attached to each of the wheel's upward and downward motion. This means the shock absorbers and coil springs of a Formula One race car don't mount directly to the control arms, rather, they are designed to fit along the length of the car. They translate the upward and downward motions of the wheel to the backward and forward movement of the spring and damper apparatus. Back at the factory, the piston rod is fitted with a piston that contains precision engineering valves. The valves are usually secured with locking mechanisms, ensuring that they remain stable under high-pressure conditions. The piston rod and piston assembly are placed into the cylinder, which is partly full of hydraulic oil. The oil level is carefully controlled to ensure the correct dampening characteristics. Extra care is taken to ensure that the piston fits snugly and moves freely within the oil-filled cylinder. To prevent leakage, high-quality bushings and seals are installed at the top of the cylinder. The components are then sealed with high-precision O-rings, usually for the prevention of fluid leakage, and the ends of the cylinders are welded closed. To prevent corrosion on the exposed parts, the shock absorber is coated with anti-corrosion material like electroplating or powder coating. To get the high-quality shock absorbers, the assembled components are put through rigorous tests, including durability, performance under load, and resistance to extreme temperatures. An example of these tests conducted on the F1 race car include the dynamometer testing, whose aim is to measure the performance of the shock absorbers under various stages of speed and loads. Formula One racing is all about speed and balance, most of which is achieved with the use of premium shock absorbers. Another set of tests are the environment tests, which include temperature, corrosion, and dust and debris tests. The shock absorbers are subjected to extreme temperatures in the climate chambers, which can easily be attained during a race, to ensure the consistent performance of the premium shock absorbers under varying thermal conditions. The components are also exposed to salt spray or humid environments to evaluate their level of resistance to corrosion and wear. All these tests are usually done in the labs with the aid of simulations and other machines, after which the F1 car is finally taken into the racetrack to reaffirm the lab results. This is called the real-world track testing. The shock absorbers are installed on the race car and then tested on the racetrack. Data loggers are used to measure real-time performance metrics such as dampening rates, temperature changes, and behavior over different surfaces. Ranging from absorbing bumps to ensuring stability at ultra-high speeds, the shock absorber is critical to vehicle performance and safety. As the design continues to evolve, they are becoming more efficient, ensuring that we all enjoy a smooth and comfortable ride, even on the roughest of roads. Let us know your thoughts in the comments. If you found this video entertaining, don't forget to like, share, and subscribe for more. Thank you for watching.